calculus, AP calculus, AB. There's too many A's and P's. AP calculus, AB. Practice question about the derivative of an integral. Well, to find the derivative of the integral, I'm going to multiply by the derivative of the top and bottom. Well, the derivative with respect to t of 2 of the top and bottom bound is 0. So the second term is just going to fall away. So I'm not even going to pay attention to that. The derivative with respect to t of t to the fourth is 3t cubed. I have to multiply that by the function ex squared, but with t to the fourth plugged in for x. So it's e t to the fourth squared. So this is, oh, I did it again. The derivative of t to the fourth, it's 4 times t to the third, not 3 times t to the third. You bring the original exponent to the front. Why didn't someone correct me on that? Well, e to the t to the fourth squared is e t to the eighth, 4t cubed times e to the t to the eighth power, which is d. Now, if you didn't know how to do that, you can use Desmos. This is Desmos times on the, I type int and I get the integral. This is Desmos time on the calculus AP exam. So I can write t to the fourth as an upper bound, and I've got e raised to the x raised squared, and then I put my dx. And I make a slider for t, and I'll just leave t at 1. And I'll just look at the answer choices. E raised to the t raised to the eighth minus e raised to the fourth. Is it e raised to the fourth? Negative 51. Nope, that's not it. 4t cubed. And you got to practice on Desmos to get fast with it. E, I'm not that fast. Raised to the t raised to the eighth minus, oh, notice that's 10.87, and you see that's answer D, so D is the answer. But if you aren't paying attention, you'd keep typing e to the fourth, and that's negative 43.7 something. Nope. Et to the eighth, e raised to the t raised to the eighth. Nope, that's only 2.71. Then I get the last one, 4t cubed times e raised to the t raised to the eighth. And that is, in fact, remember, that's part of this answer. So if I was paying attention, I'd have had it. But that's 10.873, etc., just like the original integral derivative of the integral I put in 10.873. So you can do this one with Desmos as well.